Okay. So it's time to start. Hello, I'm Dennis. I work in Red Hat, and I develop oVirt. Today, probably you heard a couple of times like, yeah, there was oVirt, and now we have kubevirt, now we have whatever, I don't care because I work in oVirt. But probably no one told me what is oVirt, and oVirt is an enterprise-grade open source virtualization system. Very nice system. I'm not going to talk too much about the oVirt itself. Come on, guys, you can just join our booth and have a discussion with us. But I would like to little bit mention how it looks internally. So in oVirt, we have three main components. We have a storage subsystem, some storage pool, and storage domains, and that's actually the place where you store all your VM data, your images, snapshots, templates, ISO images. All the data is here. And the only thing we require from that storage needs to be shared. Storage needs to be available on each host on a cluster, on a VDSM host. And we call them VDSM host, because VDSM is a tool that actually host agent that lives on your compute hardware and runs your VMs, mounts your storage. Yeah, I like to say about storage. I work in the storage team, that's why. Maintains like migrations and so on. But VDSM is really stupid thing. It only it's like a minion. Yeah, and it's same stupid. It's only controlled by the engine. The engine, a huge application written in Java, knowing all the stuff like where VM belongs, how to start them, where to run them, when to kill them. Everything is controlled by the engine. And the best part here, engine, is an application living inside of a VM. Yeah, that's true. We solved that problem. You have a VM controlling other VMs, and that VM is redundant. But why do we need that thing at all? Why do we need virtualization? Why do we need the oVirt and stuff? Answer is simple. You would like to utilize your resources, and then utilize them more and more and more. You know, we are living in the 21st century. If you buy 2 times bigger RAM, it will cost like 10% more. 2 times bigger drive, maybe 5% more, I don't know. And it's cheaper to buy a better, more resourceful hardware and slice it into several VMs. And your finance department are happy now, like, oh guys, we bought just 1 server and installed 10 services on it. Now, wow, cool. Wait a minute. Are you using them all the time? Do you really use all the resources you allocated to your VMs? And then I think, oh no, maybe not. Maybe I'm not using them. And maybe some VMs don't really need them. They say they need them, but maybe they don't need them all the time. And you start, squeezing more and more and more resources, and then you come to the dark side. You realize that some VMs or some services don't need the resources all the time. You can only allocate and provide resources to some VM for 2 hours, and then steal it and give to some other VM that need it, and so on and so on. So now you're drawn to overbooking. I hope you will never be overbooked on airline, because it's the same bet, even for VMs. And yes, oVirt is quite great in that area. We started making thing provision and all the stuff like years ago. We started with really simple approach. I'm not going to talk too much about this part of SIM provision, but you can just tell VM, dear VM, just believe me, you have 50 gigabytes, and actually you allocate, 0 bytes. And only when VM starts using some of gigabytes, you allocate it. How we can do that? Simple. As I told you, it's really ancient times. If you are running on a file system storage domain, it will be just a sparse file. I will let the gentleman enter. I said enter, not exit. Okay, so it's quite simple. You have a file with holes. You not allocate file, but you pretend you have it, and you only use it when it's actually written. I hope it will work, or probably it may. Yeah, for block domain, we use LVM, And we started using LVM for block domains in a really ancient era. There was no simple, so we invented a better scheme. We only allocate 1 gigabyte VM and start looking into it and using how much it's utilized. And when the utilization hits some threshold, say 80%, we immediately extend that volume to next gigabyte and start monitoring again. Threshold hit, new volume created. And we are monitoring, and so on, and so on. Can we do more? To be honest, not really. We don't control storage in that case. Because what I told you, the only thing we expect from a storage, it needs to be shared. It needs to be available from all the hosts. So it can be some network attached storage. It can be some NFS server everywhere. It can be anything. We don't care, and we don't control it. We can't do too much. But what if we need shared storage? We need shared namespace. Can we build it? What if we will have some kind of, say, software-defined storage, probably scalable, probably redundant? Haven't I seen one? Oh yeah, Gluster. Gluster, open source file system, running commodity hardware. On Gluster, you can export any part of your locally attached storage, and we don't care which one of the storage. So you just attach some bytes and export them. And you export those bricks, and you can combine them into volumes. And you may have several types of volumes, like just appending brick to brick to brick to increase some space, or replicating data from brick to brick, from brick to brick. So now you have some redundancy. And volume is the thing that you actually mount. And when you mount it on some client, guess what happens? Client sees all the data on that volume. And if you mount it on another one client sees all the same data on the volume, same namespace. Isn't that what we are looking for? Let's try to combine it together. Let's try to get Gluster and oVirt. And now we have hyper-converged environment for oVirt. So Gluster volumes are oVirt storage domains right now. And we use exactly same hardware to run your storage, to run your VMs, to run your management plane engine. And storage, due to Gluster abilities, is highly redundant and highly available at the same time. Amazing. We control the whole stack. Can we squeeze more from it? Yes. Yes, we can. Now, we can use LVM simples below Gluster. So, from the oVirt point of view, nothing changed. But the Gluster uses logical volumes. Here is a slide showing like how we usually split the storage you have. So usually you have some drive. We create an LVM volume group on it. We create pre-allocated volume for engine. And we create theme pool for 2 more bricks or for 2 more storage domains, sharing same theme pool. And they have same size. So now you pretend you have, say, 200 gigabytes of available storage domain space from just 100 gigabyte drive. And on top of it, you can still create your VMs. So you may create, say, 5 VMs, 50 gigabyte each. So in total, your VMs, we believe they have 250 gigabyte on top of just 100 gigabyte. And still using just 10 of them. Isn't that good? What else we have here? With a simple scheme with sparse files or LVM, we have a problem. We can grow your VMs, but we never reclaim space back. Sorry, it's not possible. Not this time. We have thin LVM. And thin pool in LVM is a quite smart thing. And when you remove some data from your VM, say this one VM, you remove some block. And your file system sends a trim command back to QEMU. And it's translated to Gluster. And Gluster translated back where? To LVM theme pool, and it's automatically reclaimed. Now your VM can not just grow, but also shrink back. Amazing. But if you remember on my first slide, I had 3 things, like utilizing more resource, squeezing, and overbooking. Now we are joining dark side. We don't have cookies here. But here we have something better. We have compression and deduplication. The typical use of any virtualization system is running almost same VMs. I don't believe that any one of you, I hope no one will just raise his hand right now, but does any one of you try to run all versions of Windows on a same virtualization system? Please say no, please say no. Okay, nobody said yes. So yeah, usually you have like, you tie it to a couple of different operating systems and probably to couple of versions of that operating system. You try to keep your environment homogeneous just to make it easier to maintain it. And when I say environment homogeneous, yeah?
Actually, there is a use case for usually heterogeneous set of VMs. That is training providers where they just need to provide everything that the trainer wants, and that means they have to maintain images for all kinds of image solutions. And thankfully, they didn't ask for all versions.
I completely agree with you. So I just got a comment that there is a use case for keeping lots of versions of different VMs for a training providers because they have to keep a lot of environments for it. Yes, you are right, but I'm right too. When you have a training provider, what you do? You have a version, single version, say for really weirdo operating system 075, for example. And now a class with 20 students comes and you make 20 copies of that weirdo 075 systems. So it's same. Yeah, you have a lot of different versions, but you still have same copies. And when I hear same copies, I think about compression and deduplication. And yes, we have it in oVirt. We really have it in oVirt. Oh, my dear video, please start running. Go, go, go. Yes. Mobile internet is working great there. Not Wi-Fi. We use virtual data optimizer, device mapper driver that plugs into device mapper so it can consume any of device mapper device and produce a new logical device that will be logically bigger. And what it actually does, can I just move it back? So what it actually, it's hard to. It starts looking what blocks are hitting your device and analyzing them. At the first stage, it checks, do I have a block consisting of the same byte? So it makes run length encoding, and if they found them, they just disappeared. We don't keep them at all. Then it starts, okay, maybe I've already seen of some of those blocks. It keeps track of blocks, and same blocks are merged together, like here, and finally they are compressed, and only after that, they are actually written to the device, saving a lot of space. We put it between our SIM pool and the storage, making SIM pool even bigger than actually storage you have. For example, you may have, say, 10 gigabyte hard drive. No, you can't buy it probably, but when I was making those slides, I made actual tests for it, and I was playing on a virtual system with really 10 gigabyte drives. So you have 10 gigabyte drive, you put LVM on it, and pretend now you have 100 gigabyte drive. And then you put a SIM pool of it and pretend you have 200 gigabyte drive. And then you have 50 SIM provisioning VMs on it of 50 gigabyte and 5 VMs. So now you believe you have 250 gigabytes, and you install operating system, and you use just 5 gigabytes on each drive, and internally it's only 4 gigabyte on your real hard drive down below. So 10 to 250. Amazing. Don't try this at home. No, come on, I did it at home. I've survived, so it's totally fine. I can give you some more real data. I made those screenshots and calculations during actually that test. When you install first VM, I use CentOS 7.3 and 7.4, like distributing them. First VM takes just 1 and 3 gigabyte on space, on a physical space, while giving about 4 or 5 gigabyte, while having about 5 gigabyte on logical space. Then next VM adds just a gigabyte, and third VM and all other VMs add just like half of gigabyte. The difference in sizes of VMs is that I installed a little bit different set of software in them, just not to keep them same, because it would be useless. So I installed just different roles with those VMs, like this VM will handle some PostgreSQL database, this VM will handle some HTTP, on this VM I will install, say, Java and so on. So it's a little bit different. But still, you have third VM used 8 gigabytes, and the increase was just half of gigabyte. What are the disadvantages? I told you it's a dark side. You will not be cut and put into the gamut, don't worry. But the problem here is that leverage works on both sides. So if you have 250 gigabytes there, you have just 10 gigabytes there. And if you try to write too much gigabyte on that side, your 10 gigabytes on that side will exhaust immediately. So you really have to be careful. You really have to monitor all that space constantly. And it can just disappear in a second or millisecond that you will not see it at all. It's like, wow, all my VMs just stopped. What I did wrong? I have a lot of space, and why it's saying that I'm running out of space? But we can help you. We can help you in oVirt. What we have, we call that physically available space a guaranteed space, because you are guaranteed to be able to write at least that number of bytes. Maybe more, but definitely not less. So trust us. And as I told you, VDO device, Virtual Data Optimizer, is a part of device mapper, so it can be stacked. You can have video on top of simple, or simple on top of video, or like layer simple video until you are tired. We can handle that. You wouldn't believe me, but we still handle all the possible configurations of your storage stack. And we actually scan it and try to find the smallest device. Even if it's still same device, maybe it's on top of another one same device, but we find a smaller device with available bytes and report it as a brick available space. You remember we have cluster down there. And then we recalculate, because we know the configuration of a volume, and there is like 10 or 9 possible configurations of volume. So for all of them, we recalculate raw brick data to the volume data. And finally, if you have linked your volume to storage domain, you need to actually set a checkbox like link it please. It will be automatically reported. So for brick, you will see how much space you have and how much space you actually have. And there is no deduplication compression savings, because that was just a clean brick, nothing to save. Sorry, guys. Same data, wrong blurring. Same data you have on the main storage domain view. So it's really important for everyone. So it's nice to have it right there. And even better, you can also configure some threshold. And when your physically guaranteed space is too low, oVirt will start automatically bugging you. Like, you are running out of space, please do something. You are running out of space. It will be sent every 6 hours, if I remember correctly, and you can get it by mail, via SNMP, via UI, everything. But that's not all. That was the biggest issue you can see, but that's not all. The compression and the duplication is safe, isn't free. Itself isn't free, sorry. And in worst case, it eats your IOPS. Because if your storage is fast enough and CPU is not fast enough, like it was in my case, up to minus 30%. Theoretically, if your storage is slow enough, like you have a spinning drive and modern CPU, it can be faster because you are having less physical I/O actually. I've seen that on my test lab. It gets like plus 20%. Yeah, I've heard that story like, oh, you can compress data on a drive and it will be faster. I've heard it from 90s, from a drive space time. Now it actually works. That's not all. We have to keep the index of SIM blocks in RAM, and you may see we use a lot of RAM for it. We also keep copy of that index on a storage space, on an actual storage, because we would like to read it on a startup and save it, and we use a lot of space for it. It's really a lot of space. But the best part here, all the calculations I showed you earlier, especially on the slide where I installed the VMs and it only gives you plus half a gigabyte, they include all the overhead. I mean storage overhead. So that's including that 1 gigabyte of RAM, 70 gigabytes per gigabyte of blah, 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 blah. It's all included. So it still makes sense. It still saves your space. So, I'm almost done. Yep. It's 5 minutes left. I'm almost done. As I told you, virtualization is about utilizing your resources, and you try to squeeze more and more and more and overbook them, and we have all the stuff to keep it sorry, and we have all the stuff to allow you to do that on any layer of your evilness. So if you'd like to overbook, here you have compression. It's not free. If you would like us to utilize it better, CNLVM and hyperconverged. If you would just like to be a little bit light evil guy who just not even evil, okay, use old scheme and you will be safe. Nothing bad here. You can't use it in any bad way. That's probably all. Thank you. Your questions? Go on.
I have to ask this question because it immediately came into my mind. Why do you deal with these cluster break stuff, then put device mappers on top, than just using an RBD volume out of a Ceph storage? Because the only thing that is missing is compression, right? So you can have snapshots with bin provisioning, all that good stuff, but why you choosing the way to layer stuff on top of each other and do this crazy amount of work?
Okay. So the question was why we are using Gluster but not Ceph, because Ceph already have all the stuff, right? Nice question. Maybe because we already started using Gluster and hyperconverged. It started several years ago, and when we evaluated Ceph, it wasn't that good. But now we support Ceph too. With upcoming release, we will have Cinderleaf, and you may use Ceph with it. And actually, you can take that video stuff, because it works just in device mapper area, and build Ceph file system on top of it. You are free for that.
Anyone else? Thank you, Dennis.
Thank you.
Mute. Okay. Unmute.